Hello students, it's me Rizwan here. In this video, you're going to learn about integration by substitution. So let us start. The first problem, integral of 2x multiplied with x squared plus 1 raised to 4 dx. Okay. Now, in this particular integrand that you see here, this is the integrand. There are three functions. Okay. Let's say the first one is this, that is 2x. The second one is this. If I take only the x squared plus 1, that is x squared plus 1. And I can say the third function is with the power, that is x squared plus 1 raised to 4. Now I'm going to take one of these three functions as a variable t. Now in this case, I'm going to take the second function, that is the x squared plus 1 as t. I'll tell you why. So t equal to x squared plus 1. Now if I differentiate this function with respect to x, I'll get dt by dx equal to 2x, which can be written as dt equal to 2x dx. Now please note that this is not like I'm cross multiplying this dx there. Okay, it is not correct because dt by dx is not a quotient. It is a notation. Okay, it is an expression. So you shouldn't think that I have taken dx. I have taken dx to this side. Okay. Now if you see this integrand, 2x dx is here, isn't it? For example, 2x and dx can be replaced with dt, and that is the reason why I have taken x squared plus 1 as t. Now for example, what if I take this function as t? So let me show it to you. So if I take t equal to x squared plus 1 raised to 4, then dt will be, you have to, using the chain rule, you will get the derivative as 4 times x squared plus 1 the whole cube multiplied with 2x dx. As you can see, I don't have this expression here, isn't it, in the integrand. And again, if I take let's say 2x, if I take 2x as t, then if I take t equal to 2x, then dt equal to 2 dx. I'm sorry, 2 dx. As you can see, this is also not going to help me, in fact. So I'm not going to use this, I'm not going to use this, and I'm going to use this. Okay? Fine. So I'm going to take x squared plus 1 as t. Now, what I can do is, I can rewrite this as integral x squared plus 1 raised to 4 multiplied with 2x dx. Okay, so I can substitute now. For example, I can write this as t raised to 4, and I can write this as here 2x dx. I can write it as dt. Okay, now this is easy to integrate, isn't it? T power 4 dt. The integral is, the indefinite integral is t power 5 by 5 plus c. Then finally you replace t with x squared plus 1, that is x squared plus 1 raised to 5 by 5 plus c. So the expression that you see here, the function that you see here, this is the integral of, this is the answer, this is the indefinite integral of the given question. Okay, so I hope you understood. So let us solve another problem. Okay, so let us consider this question. Now here I have, again, you can say there are three functions. One is, let's say 2x, the other one is 1 by x squared plus 3, and the other one is, let's say, x squared plus 3. Okay, of course you can go on saying that, okay, there are more than three functions here, which is true. I can consider, for example, x divided by x squared plus 3 on so on. But I'm just going to consider these three functions. So now here, which one of these function am I going to take it as t? Should I take this one or this one or this one? Now it is very easy to note, like the previous sum, I'm going to take this one as t. So if I take this as t, so t equal to x square plus 3. So dt will be nothing but 2x, because derivative of x square is 2x and the derivative of 3 is 0, so 2x dx. So I can rewrite the given integral as 1 by x squared plus 3 multiplied with here 2, so 2x dx. So I can substitute now 1 by x squared plus 3, I can write it as t, and 2x dx I can write it as dt. So 1 by t dt. We know that the integral of 1 by t is nothing but ln t, isn't it? ln t plus c. So finally replace t with x square plus 3. The answer is ln of x square plus 3 plus c. So this is the answer for this particular question. Fine, I hope you understood this. So let us solve another problem. Okay, in this question I am going to take t as x square minus 5 for obvious reasons, x square minus 5, and so this implies dt will be 2x, because the derivative of x square is 2x and the derivative of 5 is 0, so 2x dx. Okay, so now I can rewrite this integral as 1 by x squared minus 5 into x dx. Okay, now here I'll replace x squared minus 5 with t, so 1 by t multiplied with, now I need x dx. I have 2x dx, which is dt, which means x dx is nothing but 1 by 2 times dt. Okay, it's like taking 2 to the other side. So I will write 1 by 2 dt. So I can take 1 by 2, the constant, outside the integral sign. So 1 by 2 integral 1 by t dt, which is nothing but 1 by 2 ln t plus c. So the final answer is 1 by 2 ln of x squared minus 5 plus c. Okay, so let us see another problem. Okay, so let us consider this problem, students. Now I have here, I have x cube, I have x power 4 plus 3, then I have root of x power 4 plus 3. Okay, now which one will I take it as t? Now for example, if I take this as t, then the derivative will be 3x square dx. Now you can see here that I can't find 3x square dx here. If I take this one as x power as t, then the dt will be 4x cube dx. Now you can see that we have this x cube and dx. Okay, we have x cube dx, and if I take this as t, then the derivative will be 1 by, using the chain rule, 1 by 2 root of x power 4 plus 3 multiplied with 4x cube dx. Now you see it looks very complicated, isn't it? This looks very complicated. So this is not t and this is not t, so this is t. Okay, fine. So I can rewrite this given question like this. So square root of x power 4 plus 3 multiplied with x cube dx. Okay, so now I can replace this, I can substitute this with x power 4 plus 3 is t, so that means I will get root of t multiplied. Now I need to substitute for x cube dx. I have 4x cube dx as dt, which means x cube dx is 1 by 4 times dt. Okay, so I will write 1 by 4 times dt. So I can take 1 by 4 outside the integral sign. So 1 by 4 times square root of t dt, which is 1 by 4 times. Now square root of t is nothing but t power half. So the integral will be t power 3 by 2 by 3 by 2 plus c. So if we simplify this, you will get 1 by 6 t power 3 by 2 plus c. So which is nothing but 1 by 6 square root t power 3 by 2 is nothing but square root of t cube, that is x power 4 plus 3 the whole cube plus c. Or you can also write it as 1 by 6 okay, I'm not able to write 6 properly, so 1 by 6 times x square, sorry, it's x power 4, right? X power 4 plus 3 raised to 3 by 2 plus c. Okay, so this is the answer. Let us look at this problem now. Integral of sin x squared into cos x dx. Okay, so again I have, you can say, let's say one function is sin x, the other function is sin x squared, and the third one is cos x. Okay, if I take sin x as t, then I'll get dt as cos x dx, which is very much present here. But if I take sin x the whole squared as t, then the derivative will be 2 times sin x into cos x dx. Okay, which will be a problem here. So if I take cos x, then minus sin x dx. Let me erase this. So minus sin x dx. Okay, so you may ask me, sir, for example, sin x the whole square cos x dx can be rewritten as, for example, here I can write this as sin x the whole square as sin x into sin x again cos x dx. Then you may ask me, sir, why can't I write like that? If, for example, I have sin x cos x dx, which is dt, so dt by 2, so I can write this as half dt. And if I'm going to take this as t, that means here I'm going to take t as sin x squared. Then if you want sin x, then why can't I write it as, let's say, root t, and write it as root t dt, root t here. So we can't write like that. Of course you can do that, but it will be much simpler if you take the sin x as t, much simpler. Okay, so let me erase everything. Okay, let me take the problem again. So integral of sin x the whole square into cos x dx. So I'm going to take t as sin x, so dt will be cos x dx. So I can rewrite this integral as, this will become t square and this will become dt. So it is very simple. The integral is t cube by 3 plus c, which is nothing but sin cube x by 3 plus c. Okay, so this is quite simple. So let us look at another problem now. Okay, so integral of log x squared by x dx. So in this particular problem, I am going to take t as log x. In fact, it's log x to the base e. Log x to the base e. So dt will be 1 by x dx. So I can rewrite this integral, the integrand as log x to the base e squared into 1 by x dx. So by substituting, I'll get, this will become t square into, and 1 by x dx will become dt. So t square dt, the answer is t power 3 by 3 plus c. So log x to the base e power 3 by 3 plus c is the answer. Okay, so let us look at one more problem. Okay, so integral of x sine of x square minus 3 dx. So here I have again three functions. I have one function is x, the other function is sine of x squared minus 3, and the third one is x squared minus 3. Now if I take this one, there's no point in taking x as t, isn't it? So if I take this as t, then I'll get dt as cos of x squared minus 3 into 2x dx. As you can see, there is no cos in the given problem. Okay, if I take this as t, then I'll get dt as 2x dx. You can see that we have x dx in the problem. So I'm going to take t as x squared minus 3. So t equal to x squared minus 3 implies dt equal to 2x dx. Fine. So I can rewrite this integral as sine of x squared minus 3 into x dx. So I can substitute now. So this will become sine t, because this is t, multiplied with, now I need x dx. So x dx is nothing but half dt. So by taking the 1 by 2, I can take 1 by 2 outside the integral. So integral of sine t dt, that is half of, integral of sine t is nothing but minus cos t plus c. So the final answer is minus half of cos of x squared minus 3 plus c. Okay, so I hope you got the hang of it. So we'll just do one more problem. With that, we'll come to the end of this video. Fine. Please consider this problem. Integral of sin x by 1 plus cos x dx. So in this problem, I'm going to take t as 1 plus cos x, because otherwise there's no point in taking sin x as t. So dt will be derivative of 1 is 0, derivative of cos x is minus sin x, so minus sin x dx. So this integral can be rewritten as 1 plus cos x multiplied with sin x dx. So which is nothing but integral of 1 by t into, now sin x dx is nothing but minus dt. So minus 1 times dt. So I can take minus 1 outside the integral sign, 1 by t dt, which is nothing but minus 1 times integral of 1 by t is ln t plus c. So minus 1 times ln of 1 plus cos x plus c. So this is the answer. Or you can also write it as, you can take this minus 1 to the power of 1 plus cos x. So I can also write it as ln of 1 by 1 plus cos x plus c. Okay, so I hope you learned how to solve problems where you need to use substitution, how to find the integrals where you need to use the substitution method. Yeah, thank you very much for watching this video, students.